Professor V. In this video, we're going to review all of the concepts that are covered in Unit 3 from the AP Calculus AB and BC exams. It's basically all things differentiation, differentiating composite functions with the chain rule and other rules, product, quotient, implicit differentiation, and inverse functions. So I'm just going to work through examples, going through all 6 components of this unit. And then if you need any more in-depth video lectures, I will link them in the description box below. But let's just jump right in. So the first thing we're going to review is the chain rule, 3.1. So the idea when you're taking the derivative and you have a composition of functions, you need to apply the chain rule, meaning you start differentiating the outermost function, leaving everything inside alone, and you just keep working your way in one layer at a time. So you start by taking the derivative of f, because that function was on the outside. Notice we've left g of x alone. We didn't take its derivative. And then you start chaining or multiplying the successive derivatives for the functions that are layered inside the composition. And like I said, if you need a recap or more basic examples of the chain rule, I have a video linked in my description where I go through exactly how it works with super basic examples. But let's just jump right in and see where you guys are at. Just remind yourself, you're going to start from the outside, work your way in one layer at a time. So find the derivative of each function. Starting with the outermost function, the derivative of sine something is what? Cosine something. Very good. So y prime is going to be cosine of, now don't take the derivative of the inside function yet, only one at a time, starting from the outside, remember? So we're going to have cosine of 3x squared plus 4, and then you chain or you multiply by the derivative of the next layer. So the next layer or the next function inside the composition is 3x squared plus 4. Derivative of 3x squared plus 4 is just going to be 6x. And then this looks a little ugly. I would put the 6x in the front, and then you have cosine 3x squared plus 4. Good? Okay, let's box that up. Perfect. Okay, next one. H of x is e raised to the 2x cubed minus 5x. So again, h prime of x, the outermost function, just ignore everybody else. Derivative of e to the something is what? It's e to the something. Now I'm going to chain or multiply by the derivative of the something. So the derivative of 2x cubed minus 5x is going to be 6x squared minus 5. And then again, it'll look better if we put 6x squared minus 5 in front. Make sure you keep those parentheses, and then e to the 2x cubed minus 5x afterward. Okay? Very good. Okay, next one. G of x equals cosine of x over 1 plus sine x to the 4th. I love this one. I've put it on an exam so many times. So g prime of x, what's the outermost function? Just kind of blur your eyes. We have this whole mess raised to the 4th. So the derivative of something to the 4th, you bring the 4 down front. I'm going to leave everything alone that's inside the parentheses and change the exponent to 3. Isn't that what we do? Now don't change, don't mess with anything that's inside. We're doing the outermost layer first, that's it. So just leave it, cosine x over 1 plus sine x. Now we're going to chain or multiply by the derivative of the next layer. So this inside function here, well, I need to use the quotient rule. Exactly. So here we go. I like to sing the little song that my calc teacher taught me over 20 years ago. We've got low, the denominator, d high, so that's derivative of the numerator, minus high, d low, that's derivative of the denominator, over low, low. So low d high minus high d low over low, low. Or you could also say square the bottom, away you go. All right, how we doing? Now this one just simplifies so beautifully. That's why I've put it on exam so many times. We're just going to distribute, clean up. So this is 4. If you want, we can distribute that exponent of 3, but maybe you wouldn't know to do that just yet, so I won't either. And then let's see what's going on over here. We'll have negative sine x minus sine squared x minus cosine squared x over 1 plus sine of x squared. And then I'm noticing I can take a negative out from everybody. I'm going to put it all the way in the front, okay? So I'm going to write this as -4. Now I'll make this cosine cubed x over 1 plus sine of x cubed. And then all of these are positive. So this is going to become sine of x plus sine squared x plus cosine squared x over, that's right, 1 plus sine of x squared. Do you notice something? Why, yes, this is just 1. And that means in the numerator, I have 1 plus sine x. Isn't that exactly what I have down here? So this will all cancel out with one of those 1 plus sine x's from the bottom. And then now I can put everything together for my final answer. I have -4 cosine cubed x over, count them up. I've got 3 1 plus sine x's and a fourth one right here. So 1 plus sine of x to the 4th, okay? Very good. Now, occasionally there's a student who wants to distribute the 4 and then just do quotient rule. But if you do that, it's going to make for much messier simplification, believe me. So start on the outside, work your way in, and this will be the way to most easily arrive at the correct answer. You know what I mean? Okay, the next one's kind of spicy. Are you ready? Y equals e raised to the cosine of t over 9 to the 4th. So here we go. Y prime, we basically have something to the 4th. That's right. So bring the 4 down front. Just put blank parentheses. Remember to change the exponent by subtracting 1. Now rewrite exactly what you had inside. Don't change it. Okay. Now we move on to the next layer, times. Well, what's the next layer? You basically have e raised to the something. So what's the derivative of e to the something? It's e to the something. Don't do anything to the something. Now you can move to the next layer. What's the next layer? The derivative of cosine something. So the derivative of cosine something is negative sine something. We're almost there, guys. We're almost there. Next layer, the derivative of the exponent, t over 9. You could think of t over 9. T over 9 is 1/9 times t. So the derivative is just going to be 1/9. Very good. Now we're done with calculus. We just got to clean up this hot mess. So let's see. Constants come to the front. 4, negative, and 1/9. So that's going to be -4 over 9. And then notice here, I have 3 factors, right? E cosine t over 9. And here's a fourth one. I've got 4 of them. Oh, and then I have just one of the sine of t over 9s. So sine of t over 9, I'll put you here because you're all by your lonesome. And then we've got e to the cosine of t over 9 to the 4th. Okay, and then now I can simplify. Oh yeah, when you have power raised to another power, we multiply those exponents. So the final cleaned up, cutesified answer, -4/9 sine t over 9 times e to the 4 cosine of t over 9. Boom. Box that with pride. That was beautiful, guys. Beautiful. Okay, how you guys doing? Now let's look at another example, classic AP style, where they don't actually give you the function. They love to give you a table. Table of values for f, g, f prime, and g prime is given. So first, if h of x is f of g of x, find h prime of 1. So what we need to do is write out the chain rule formula and then use the table to fill in and find what the value is going to be. So h prime of x is going to be, remember, starting with the outermost function. So f prime of g of x times, now move to the next layer, derivative of the inside function is g prime of x. Okay, first you have to do it all in terms of x. Don't plug in 1 just yet. Now we can substitute in 1 since we have our formula. H prime of 1 is f prime of g of 1 times g prime of 1. So now let's go to the table. This time it's kind of backwards. We're going to start with the inside function, g of 1. Where's g of 1? It's right here. It's 2. So this is 2. So I need f prime of 2 times what's g prime of 1? G prime of 1 is 6. Okay, perfect. Now let's figure out what's f prime of 2. Here's 2. F prime of 2 is 5. Times 6, this is 30. Voila. How'd you do? Okay. I would expect something like this on the test. In some form. Okay, here we go. Capital H of x is g composed with f of x. Find h prime of 1. So same idea, they just switch the order of the composition. So write the formula first for h prime of x. Don't substitute in 1 just yet. If you plug in 1, you're going to get a constant, and then the derivative of a constant 0. So you never plug in the value, the specific value for x, till after you've done doing your calculus, you know. Okay, h prime of x is going to be g prime of f of x times f prime of x. Good. Now we go to the table because we need h prime of 1, right? So it's going to be g prime of f of 1 times f prime of 1. Let me erase all the colors from before so they don't confuse you. Okay, f of 1 is 3, so this will get replaced with a 3, and then keep that g prime there. And then, I need f prime of 1, so f prime of 1 is right there, it's 4. This is 4. Okay, perfect. So what's g prime of 3? Here's 3. G prime of 3 is 9. So this is going to be 9 times 4, which is 36. Yay, perfect. Nice job. Okay, next topic in Unit 3 is implicit differentiation. I just put out a very new excellent video only on implicit differentiation. If you haven't checked it out, I'll link it here in the top right. Remember, when you're differentiating some equation that relates x and y, and you're not isolating y in terms of x, you need to use implicit differentiation. And typically, we will differentiate with respect to x. So when you take the derivative of functions of y, all you need to do is multiply by dy dx. It's the chain rule in action, okay? That's the short recap. Watch the video if you need a little bit more than that. So here we go. We're going to find dy dx. We have e to the 3x equals sine of x plus 2y. So differentiating with respect to x, derivative of the left-hand side. Don't forget we have chain rule. It's going to be e to the 3x times 3. And then on the right-hand side, again, chain rule. So derivative of sine something is cosine something. And then we're going to take the derivative of the something. So I'm doing chain rule, chaining its derivative. Derivative of x is 1. And then derivative of 2y. Now that's a function of y. So derivative of 2y is 2 times, I have to multiply by dy dx. And the reason we do this is because we're differentiating with respect to x, but we have here a function of y. So this variable is not the same one as the one we're differentiating with respect to. We really technically did that step here. It's just this is a function of x. So we have dx dx, which you don't see. It's just 1. Okay, so you really have been doing this all along. It just appears when you do implicit. Okay, from here, we want to isolate dy dx. So I need to distribute or multiply this out. So we have 3e to the 3x equals cosine of x plus 2y plus 2 cosine of x plus 2y times dy dx. Okay, and then I'm just going to rewrite it. All I need to do is subtract this over to the other side, divide by this. I think at this point we can all just jump there, right? So dy dx is going to be 3e to the 3x minus cosine x plus 2y divided by 2 cosine x plus 2y. Beautiful. Good. Let's do another one. We have cosine of xy plus x to the 5th equals y to the 5th. Pause the video. Try this one on your own. Let's see where you're at. Did you pause it? I hope you did. Because, it's all fun when you're watching me. It looks kind of easy. You can follow along. I am a professional. You need to make sure you try them on your own more than you passively sit and watch, because that's the real way to test if you actually have mastery, I won't be there to take the AP test with you, sorry. Okay, derivative of cosine something is negative sine something. Then I'm going to chain or multiply by the derivative of the inside, and I need to use product rule. When you do the product rule, just remember they take turns. So your two functions are x and y. X, it's not your turn. You stay here. Derivative of y is going to be 1 dy dx, good. And then plus derivative of x is 1, and I leave y alone. Yes? Okay, all of this is the derivative of cosine xy. Plus 5x to the fourth. Technically, there's a dx that we don't see. Equals derivative of the right-hand side is going to be 5y to the fourth. Since, yes, it's a function of y, then we need dy dx. Okay, in this case now, you see how we have dy dx appearing in more than one place in the equation? So we're going to multiply this out, get all the terms that have dy dx on the same side of the equation, and everyone who doesn't have dy dx gets exiled to the other side. So we've got negative x sine of xy dy dx minus 5y to the fourth dy dx equals negative 5x to the fourth plus, if I distribute this, I'll have negative y sine of xy, so it's going to be positive y sine of xy over here. Are we okay? Like, Professor V, that was kind of aggressive. I know, you're fine. Okay, I can factor out dy dx from both these terms. So let's do it. Dy dx times negative x sine of xy minus 5y to the fourth equals y sine of xy minus 5x to the fourth. And then last step, dy dx equals y sine of xy minus 5x to the fourth over, let me factor this negative out, and then I have x sine of xy plus 5y to the fourth. And then to really bring it on home, you guys, anytime you multiply by a negative, that reverses the order of subtraction. So all I need to do is like steal this little guy up here, switch the order of subtraction, and I won't need to write it anymore. So that'll look even better if I write this as 5x to the fourth minus y sine of xy over, let's put this guy first, 5y to the fourth plus x sine of xy. Good? Great. Okay, let's look at another classic problem. Example says, find the slope of the tangent line to the curve x squared plus xy plus y squared equals 7 at 2, 1. So always remember, when they want slope of the tangent line, m tan is equal to the derivative evaluated at whatever point's given. So basically we have to find dy dx and then plug in 2 for x, 1 for y. So here we go. Here's our equation that we need to differentiate with respect to x. So derivative of x squared is 2x. And then product rule for a derivative of x times y, that's going to be x. Let's leave it alone. Derivative of y is 1 dy dx. Good. Plus derivative of x is 1, and then leave y alone. Beautiful. Plus derivative of y squared is going to be 2y dy dx, and this all equals 0. So then remember, the terms with dy dx, you want to group them together on the same side of the equation. Whoever does not have dy dx gets exiled to the other side. So we've got x dy dx plus 2y dy dx equals negative 2x minus y. And the whole reason you want all the terms with dy dx together is so that you can factor it out. So we have dy dx times x plus 2y equals negative 2x minus y. And then, yep, to get dy dx, you're just going to divide out that x plus 2y. So we've got negative 2x minus y over x plus 2y. Good. So then to get the slope of the tangent line, I'm just going to take that derivative, dy dx, and evaluate it at 2, 1. So we have negative 4 minus 1 over x, which is 2, plus 2y, which is going to be 2. So that's negative 5 over 4. Boom. Done. Sorry for being squished. Woo, what's that? That's not a box. I don't like it, guys. Hold on. That's not the vibe. There we go. Okay, perfect. Last one on this topic. At the 2 points where the curve x squared minus xy plus y squared equals 4 crosses the x-axis, the tangents to the curve are parallel. What is the common slope of these tangents? So I know we're going to need dy dx, but notice they didn't give me a point this time like they did previously. But they told me they're interested in the slope of the tangent line where this curve crosses the x-axis. So I have to go find the ordered pairs myself. And a curve crosses the x-axis when y is equal to 0. So that's the key. This curve crosses the x-axis when y equals 0. Do you know what this curve is? It's a circle. Yeah, we can graph it in a second if you want to see. Okay, so if I substitute in y equals 0 into this equation for the curve, we'll get x squared minus x times 0 plus 0 squared is 4, which tells me x squared is 4, so x is plus or minus 2. And I got those x values by substituting in 0 for y. So those are the 2 points where I need to figure out the slope of my tangent line. I need dy dx at 2, 0 and negative 2, 0. Good? Okay, from here, the problem plays out the exact same way. Notice it's almost identical. I just have a minus xy, and here we had a plus xy. So I'm just going to go quickly differentiate. So we've got 2x minus, I would put parentheses so don't mess up if I were you, x times dy dx, product rule, plus 1 times y, plus 2y dy dx is 0. Keep dy dx on the left, and I'll factor it out. So then I'll have dy dx times 2y minus x equals positive y minus 2x. And then solving for dy dx, we get y minus 2x over 2y minus x. Okay, perfect. So I need to evaluate this derivative at 2, 0 and negative 2, 0. And actually, I should get the same value at either point because notice here it says the tangents are parallel. What is the common slope? So I should get the same slope at both the points. So I guess we only need to plug in one of them, but just to be safe to make sure you didn't mess up, I would plug in both, you know. I would be a little paranoid if I was taking an AP test. I'd be like, yeah, let me do my due diligence and really just be a thorough little student. Okay, let's evaluate it at positive 2, 0. That would be 0 minus 4 over 0 minus 2, negative 4 over negative 2, that's 2. And then let's get the derivative at negative 2, 0. Boom. Love it so much. 0 plus 4 over 0 plus 2. Oh, check that out. That's also 2. Woo! So our answer is 2. Good? Great, Professor V. Okay. Then we can move on to the next idea. Differentiating inverse functions. So you're just going to really have to put this formula to memory. The derivative of the inverse of a function is 1 over f prime of f inverse of a. So let's look at an example here. Like in this case, f of x is x cubed plus 2x plus 1. It's going to be basically impossible to get x by itself as a function of y. So if we need the derivative of the inverse function, we're going to utilize this formula here. Now, the only funky thing is they want f inverse prime of 4. I have to figure out what f inverse of a is. In this case, f inverse of 4. You might be like, what in the world? So f inverse of 4 means what x value gives me a function value of 4. You literally have to look at it and guess because you won't be able to solve explicitly. But here's the thing. It's usually some nice number like 0 or 1, or maybe if they get wild, negative 1. So I'm just going to guess right now x equals 1 because I'm feeling good about it. And then it's like 1 plus 2 plus 1. Yep, that's 4. So f of 1. Do you see what I'm saying? I know. I hated this part. When I was taking this class, I'm like, this feels yucky. I don't want to guess on my AP test, but you know what? It is what it is. It won't be 2/7. It won't be 5. Do you know what? It's just not going to be that wild. So you can relax. Okay, here we go. So just direct application of the formula. There's not too much else to do. So F inverse prime of 4 is 1 over F prime of F inverse of 4. So this is going to be 1 over F prime of, what did we figure out F inverse of 4 was? F inverse of 4 was 1. It's the x value that yields a function value of 4. So I need 1 over F prime of 1. Okay, so let's just take F prime of x, very easy, relaxing polynomial. Look at that. F prime of x is 3x squared plus 2. So then F prime of 1 is going to be, you betcha, 5. So this is going to be 1/5. Boom. Okay, not too terrible. Ooh, of course, you know they're going to ask you to do some with a table. Oh yeah. Let f be a differentiable and invertible function. Selected values of f and f prime are shown below. Using the table, find f inverse prime of 6. This should make you less nervous. You don't have to guess. I would like these better. When I was doing this exam, it was over 20 years ago, but I did take the AP calculus exam. Okay. So we have f inverse prime of 6 is 1 over f prime of f inverse of 6. The more you write the formula down, the faster you'll memorize it. Okay, so let's use the table. What's f inverse of 6? That means you look for a function value of 6 and you say, who was x? It was 2. So all of this highlighted stuff is going to be replaced with 2. So I need 1 over f prime of 2. Back to the table. What's f prime of 2? It's 3. Very good. So this is 1/3. Are you okay? Slightly traumatized? If you know the formula, it's not bad. And you just got to make sure you keep it straight. Keep it straight. Ooh, this one's spicy. I love it so much. G of x is f inverse of x squared. Ooh, find g prime of x. So we have to do, oh yeah, chain rule along with this formula too. Great. Okay, first let's write out what g prime of x would be equal to. So notice we have something squared. So bring the 2 down front, leave the something alone. New exponent is 1. Then, yes, multiply by the derivative of what's inside. What's the derivative of f inverse of x? The formula we just have up above. 1 over f prime of f inverse of x. Whoo! Okay, now we need g prime of 6. Okay, so g prime of 6 is going to be 2 times f inverse of 6. Let me just write it like this. Over f prime of f inverse of 6. So come to the table, and let's find f inverse of 6. That means the function value is 6. What is the input, the x value? It's still 2. They didn't change the table on us since the last problem. So this is 2 times 2 over f prime of 2. And then again, oh my God, this is so crooked. What in the world? What's f prime of 2? Come to the table. F prime of 2 is 3. So this is 4 over 3. Good? If you got that, you're thriving. You're in a great position. Okay, here we go. Moving on. Differentiating inverse trig functions. Put these to memory. You're going to need them so much, especially when you start doing integration, anti-differentiation. Some things to notice. Derivative of cosine inverse is just the negative of the derivative of sine inverse. That should make sense to you in your soul. Cotangent inverse derivative is the same as tan inverses. It's just got a negative. You see that? So you really only have how many to memorize? Let's be honest. It's not that dramatic. You only have 1, 2, 3 to memorize. The cofunctions are just the negatives of these guys. So if you have these 3, you are in business, my friends. Okay, here we go. I'm excited. So y is negative cosine inverse of 6x plus 3 over 9. And they're asking us to differentiate with respect to x. All right, you got it. So dy dx. Now here's the lovely thing. You see how they put a negative in front? So this negative will cancel with the negative here. So I just won't even have to write it anymore. So here's the tricky thing. Whatever this argument is, that's what you square, no matter how messy or disgusting it is. Yep, you do 1 over square root 1 minus whatever the argument is squared. Then chain rule, multiply by the derivative of what's inside. So please don't do quotient rule. There's no variables in the denominator. It's not necessary. Just think of this as 6x over 9 plus 3 over 9, which is 2/3 x plus 1/3. What's the derivative of that? Why, just 2/3, exactly. Okay, now we have to clean up. So the calculus is done. Can you simplify the answer enough so you can identify it? Say this is on the multiple choice. So we've got a 2 up top. Now this 3, what am I going to do with it? I'm going to smush it, distribute it underneath the radical. When it comes underneath the radical, for it to still really be a 3, I have to square it and make it a 9, because square root of 9 is equal to 3. So it becomes a 9. And then I've got this 1 minus, let me distribute those parentheses, 6x plus 3 squared over 81. Exactly. Okay, and for a hot second, things are looking gross, but it's okay. So 2 over square root, this is 9, minus, I'm going to distribute 6x plus 3 squared over 9. Now, we cannot leave it like this. No, we cannot. Because we have a complex fraction. We have a fraction inside of a fraction. So I'm going to multiply, very good, by really square root of 9 in the denominator, because this 9's underneath the radical. So I have to multiply by square root of 9 in the numerator, which is what? It's a 3. Very good. So now I've got 6 over square root, distribute. Ooh. This is going to be 81 minus 6x plus 3 squared. Okay. How do you feel? Do you hate it? That's okay. You can hate it. It was a little disgusting. All right, next one. Y equals tan inverse of the square root of 5x. Okay, think of it more like tan inverse of square root of 5 times square root of x. That's just a constant. So derivative of tan inverse something is 1 over 1 plus the something squared. Then I have to do chain rule, multiply by the derivative of the something. So derivative of square root of 5 times square root of x. Square root of 5 is just a constant. Leave it alone. Derivative of square root of x. Remember, it's x to the 1/2. So it would be 1/2 x to the negative 1/2. Okay. So let's clean up. So we have rad 5 over, let me write this as 2 rad x. So this becomes 2 rad x in the bottom. And then I have times the quantity 1 plus, now it's just a 5x once I square this, right? And then from here, the last thing I would do is just rationalize the denominator. So to get rid of that rad x, let's multiply by rad x top and bottom. I would leave it as rad 5x over, now I just have 2x times 1 plus 5x. Okay, cute. Okay, let's look at some more. Ooh, my very favorite problem's coming up. Not this one, the one after. Okay, y equals sine inverse of e to the 6t. Ooh, you should pause the video, do this one on your own. This one's a good knowledge check moment. Okay, y prime, derivative of sine inverse something is 1 over square root 1 minus the something squared. Then, chain rule, multiply by the derivative of the something. So derivative of e to the 6t is going to be e to the 6t times 6. Woo, calculus is done. Just clean her on up. 6e to the 6t over square root. This is going to be 1 minus Remember, when you raise a power to another power, you just multiply those exponents. So it'll be e to the 12t. Voila. Love it. Okay, are you ready for one of my favorite problems ever? Yay. Well, y equals x sine inverse of x plus square root of 1 minus x squared. Okay, here we go. I'm going to have to do product rule, right, for the first terms. Derivative of x is 1. Leave the other guy alone. Plus, now I leave x alone. Derivative of sine inverse of x is 1 over square root 1 minus x squared. Okay, plus, now I need derivative of 1 minus x squared underneath a radical. So remember, that's 1 minus x squared to the 1/2 power. So when I take the derivative, it's going to be 1/2, leave the 1 minus x squared alone, subtract 1 from the exponent, and then I have to multiply by the derivative of what's inside, which is negative 2x. All right, calculus is done. Now we clean up. So this is sine inverse of x plus x over square root 1 minus x squared minus, do you see this 1/2 and 2 will cancel? So then I'm just left with x over square root 1 minus x squared. How beautiful. Who sat there and made sure these two terms would cancel in such a satisfying manner? Oh my. So the derivative is just sine inverse of x. Lovely. Okay. Good, good. So now let's basically recap. Part 5 is all about selecting procedures. So for the following exercises, state all the differentiation rules that need to be used to find dy dx and then find it. Okay, so the first one we have is y equals e raised to the sine of x squared. So for this problem, we just need to use the chain rule several times. We're going to chain several times. So dy dx, let's go ahead. Derivative of e to the something is e to the something. Then work your way in one layer at a time. Here's outside layer. Next layer, derivative of sine something is cosine something. Keep working your way in. Derivative of x squared is 2x. Beautiful. Then just clean it up. So this is 2x. I put that in the front, cosine of x squared, and then put e to the sine of x squared last. That looks good. Okay, next one, y equals x squared e to the 3x over sine x. So I definitely need to do quotient rule. I have variables up top, variables in the bottom. While I'm doing the quotient rule, notice in the numerator, I'm going to need to do product rule and chain rule because we have e to the 3x. Okay, so here we go. Y prime, I'm going to say the little rhyme. So we have low d high, derivative of the numerator. I would open up some parentheses. So product rule, 2x e to the 3x plus derivative of e to the 3x is 3e to the 3x. Leave x squared alone. It already had its turn. So this is low d high. Then I need minus high, that's the numerator. D low, derivative of the denominator's cosine x. Square the bottom, away you go. Okay, from here to clean up, I would look through and say, what can I factor out of everybody? I can take an x e to the 3x out, just one x, and an e to the 3x. So let's do it. X e to the 3x. Then I'm going to have 2 sine x plus 3x sine x minus x cosine x. Yep, over sine squared x. Does anything else cancel or clean up? Sadly, no. But here we are, ready for action. Okay, next one. Well, this problem involves implicit differentiation. So anytime we're doing implicit differentiation, we're applying chain rule properties. And in this particular case, we also need the product rule. Okay, so here we go. We've done one very similar many times. 2x plus product rule, x times 1 times dy dx, that's the derivative of y, plus derivative of x is 1, leave y alone, plus derivative of y squared is 2y dy dx is 0. Don't forget to make this a 0. Oh my God, so many times my students forget and they leave it as a 7 and it ruins the whole problem. And I get so sad for them. All right, dy dx, I can factor it out from x plus 2y. And then everybody else does not have dy dx. And then I can just divide by that x plus 2y. Let's put negative 2x first. Let's go in alphabetical order. Over x plus 2y. Okay. This one's the grand finale. Look at this one. I'm so proud. Let f be an invertible function such that f of 2 equals 5 and f prime of 2 is 4. And let g of x be natural log of f inverse of x. Find g prime of 5. Oh, so good. Okay, so you really have to use quite a few rules. We're going to be doing chain rule. And then we're going to also need to use the derivative of an inverse function. Okay, so we've done one similar, but not as spicy as an ln. Oh me, oh my. Okay, here we go. First, you're going to find g prime of x, then you plug in 5. Remember, don't plug in this constant in the beginning. Then when you take the derivative, you're just going to get 0, and you're going to be like, what the heck happened? Okay, so the derivative of ln something is just 1 over the something. And then chain rule times the derivative of f inverse of x is, now we use our formula, it's 1 over f prime of f inverse of x. How are we? Are we great? Okay, so now we can say, okay, I want g prime of 5. So this is going to be 1 over f inverse of 5 times f prime of f inverse of 5. Now they better have given me everything I need because I have no equation, no table. So let's see. What's f inverse of 5? Oh, look right here. F inverse of 5 is 2. Okay, so f inverse of 5 means what x value gives me a function value of 5. So all of that is 2. So is this. That's a 2. Okay, so we have 2 times f prime of 2. Are we all right? Let me keep the color coding going for you. Beautiful. Did they give me f prime of 2? Why, they did. It's right here. It's 4. Let me not have, it's 4. So all of this is 4. So this is 1 over 2 times 4, 1/8. Whew, we made it, guys. I don't know what shape that is, but I'm kind of liking it. Okay. Last idea is with higher order derivatives. Are you ready? Find y triple prime if y equals 6x sine x. Okay, let's keep our wits about us and differentiate thrice. Oh yeah. So y prime, it's product rule time. Let me treat 6x as one function and then sine x as the other one. Okay, 6, leave sine x alone. And then now leave 6x alone. Derivative of sine x is, good, cosine x. First derivative's done. Keep it going. Y double prime. Derivative of 6 sine x is 6 cosine x plus product rule again. So derivative of 6x is 6. Leave cosine x alone. Plus, now leave 6x alone. Derivative of cosine x is negative sine x. So now clean this up. See how these are like terms? Oh yeah. So make this 12 cosine x minus 6x sine x. Okay, one more time, guys. We need a third derivative. Y triple prime. Derivative of 12 cosine x is negative 12 sine x. Minus, I put some parentheses. It's too dangerous, guys, not to. Especially if you're just learning this. So product rule. Let me highlight for you. This is one function. This is the other function. So derivative of 6x is 6. Leave sine x alone. Plus, now leave 6x alone. And then derivative of sine x is cosine x. Clean up, clean up. Now we have negative 18 sine x. Ooh, minus 6x cosine x. Beautiful. Okay. And for the grand finale, find the second derivative with respect to x of Yes, this time we're going to have to do implicit. X squared minus y cubed equals 6. So fun. Okay, so first let's find dy dx, then I'll show you what to do to get the second derivative. So differentiating term by term with respect to x, derivative of x squared is 2x. Derivative of negative y cubed would be negative 3y squared dy dx, and all of this equals? Very good, 0. 0. Derivative of a constant, 0. So dy dx equals 2x over 3y squared. Perfect. That's the first derivative. Now I'm going to differentiate this again with respect to x. So my second derivative with respect to x, quotient rule, yes? Okay, so we've got low d high minus high d low. Pay attention here. Derivative of 3y squared is going to be 6y dy dx, since it's a function of y, over the denominator squared, which is 9y to the 4th. Now, what do I do from here? Well, to clean up, I'm going to need to replace dy dx with all of this, with what we found earlier for our first derivative, okay? We got this. So this is 6y squared minus, this will be 12xy times 2x over 3y squared over 9y to the 4th. And then let's see, we should hopefully be able to cancel quite a bit. So 3 and 12, that gives me 4. One of the y's goes away, but not all of it. So this is going to be 6y squared minus 8x squared over y over 9y to the 4th. And then this is still a complex fraction. That's a no-no. Multiply through by y, right? And then we'll have 6y cubed minus 8x squared over 9y to the 5th. Now, you could stop here. A lot of the time, though, when you're doing implicit differentiation, the second derivative will involve in some way the original function. So what do I mean by that? You see how x squared minus y cubed was 6? Do I see an x squared minus y cubed here? No, I don't. But you know what I can do? So let me write that down. X squared minus y cubed is 6. If sometimes you'll see like an x squared minus y cubed popped up, and then you could just like replace the whole thing with the 6. I'm going to kind of force it to happen. I'm going to make this 6y cubed minus 6x squared minus 2x squared over 9y to the 5th. Do you agree that's still equivalent? This is negative 8x squared. I did that though, so I can factor out from here now a negative 6. If I take out negative 6, then I have x squared minus y cubed minus 2x squared over 9y to the 5th. And then what can I replace this x squared minus y cubed with? 6. Exactly, 6. So then this becomes negative 36 minus 2x squared over 9y to the 5th. Would I leave it like that? No, I would take the negative 2 out and then make it x squared plus 18 over 9y to the 5th. Okay, you might say, Professor V, I would have never thought to do that. Well, I've shown it to you now, so you're aware, so be on the lookout. Okay, that one might take more practice. So that concludes the Unit 3 recap. Like I said, it was kind of fast and furious. If you need more in-depth video lectures on any of the Unit 3 topics, they're all linked in the description. Make sure you give this video a thumbs up if you found it helpful. Subscribe to my channel if you haven't already, and I'll have more AP Calc, AB, BC unit review videos coming soon. So make sure your notifications are on. Don't forget to follow me on Instagram and TikTok, Math with Professor V, and I'll be back sooner than later, guys. Bye.